what's like one of the really exciting things about this chat for me is look how young they are. Like we're talking to people who are young enough to have a long runway in front of them for developing the industrial changes that are happening as we speak. So I'm just going to start out by asking you guys to say something about yourselves. Probably easier for you to do it than me. So Leonel, why don't we start with you and just
Sure.
tell kind of a little bit about yourself. I want to say when I contacted Leonel to ask him to do this, he was working at Whirlpool. Then he contacted me back and said, now I'm somewhere else. So tell us.
Yeah, thanks. Thanks for the invite. Happy to be here. So my name is Leonel Leal. I'm originally from California. I've had a broad range of experience, heavily originally within automotive, a little bit non-traditional. Started my career at Toyota, which is a traditional company, but then went into Tesla to launch the Model S with the initial electric vehicle architecture there. I spent some time at Faraday Future, which is a competitor electric vehicle company in California as well. The last 2 years, I was at Whirlpool doing concurrent engineering, advanced manufacturing, and digital transformation globally. And as Kathleen said, I recently joined Symbotic, which is looking at automation within logistics and distribution space.
And it's in Boston, but you like Michigan. You're thinking of
Yes, that's right. It's based in Boston, but I live in Michigan, and I like it here. So yeah, even though I like California more, I still gotta say that, but I like it here enough.
Charlie, you want to tell us about yourself?
Sure. So I'm Charlie Wood, Director of Engineering Research Development at Fast Radius. So Fast Radius, a little bit about us, we're like a digitally enabled manufacturing company, globally recognized as like a WEF lighthouse, headquartered in Chicago. So what do? We're kind of manufacturing meets software. So our paradigm, our play is that we're using software as a way to build and scale manufacturing sites like across the world. So understanding, how we collect data, how we build out the infrastructure for manufacturing and to drive scale and functionality for our customers. So we make parts. That's the easiest way to say it. A little bit about me. So I've been with Fast Radius for 3 years. My background's in computational engineering and material science. So I have a PhD from Northwestern, mechanical engineering, where I did research with Lockheed Martin, Goodyear, companies like that, really understanding, doing research and develop for them in an academic setting, but that was highly applied. And then before coming to Fast Radius, I spent time in the consumer electronics industry, another industry that moves really fast and uses a lot of computational tools to de-risk programs.
Awesome. Kyle, you're next. Tell us about yourself. You guys are like amazing.
You set the bar that high, Kathleen, and then I got to introduce myself.
I know, right?
That hurts. It hurts. So Charlie and I have had somewhat, from a speed perspective, a somewhat opposite path. I started in naval nuclear propulsion as a design engineer, so very, very slow and methodical, right? Industry. Moved to primary metals at Alcoa. Now I work for Rockwell Automation. I run the Advanced Technology Laboratory. We're the 5 to 7 years out ahead of the company, or ahead of the product and company development, where we're de-risking optionality, right? So we create knowledge. Either don't go here, or yeah, this is a direction we should or could go. Charlie, I think, said it really well. The way I describe what Rockwell broadly does is we make the stuff that people use to make stuff. So anything you need to produce a line that automates the thing that's really what we're doing. So very, very capable devices, but they're sharp-edged, right? They have, because they're capable, they have lots of configuration. That means that they're potentially complicated to implement and use. And so balancing all those requirements. My laboratory covers everything from software, augmented virtual reality, to control theory. So very, very diverse group.
So thank you so much, all of you, for joining us today. It's going to be interesting to hear your insights. Let's just start with, you've all got a unique inside view of these big changes that we're seeing in the industrial landscape. Can you just kind of talk about your view of that? How is the industrial landscape changing, and how is manufacturing changing? And jump in. You guys are perfectly
Yeah,
capable.
I would like to jump in real quick, Kathleen. I think one of the biggest things is if I can summarize it with a couple words, is agile and connected, to build resilience, right? So one of the things, and obviously this is hyper, out there because of COVID, but I think even before COVID, a lot of the trends within manufacturing about, as we transition into Industry 4.0, as we transition into data, what does that mean? And not just how our factories look, but how do we get to the end state of what we're producing? And what I'm talking about is that framework to get design engineering, manufacturing engineering, cross-functional work streams that allow us to get products into market faster. So for me, it's really about the big changes is as we connect those work streams, how do we make better products faster? Bottom line, I think you look across any industry today, and there are some people that are doing this very well, but by far and large, most manufacturers have the same lead times and the same complications and failure modes they had 30 years ago. And there's a lot of reasons for that, but to me, that's the kind of the wicked problem that's out there in manufacturing.
Leonel, I think you nailed it in a lot of sense. This is Kyle, where resilience is the key, right? And that's where people are headed. And there's this balance that we see manufacturers trying to drive. As we become a more connected society, Bruce Schneider's book, Click Here to Kill Everyone, was an absolute must read when it comes to cybersecurity. As we bring physical systems into the internet, right? You're now not risking just financial or like you're not just risking financial or reputation. You're risking humans, right? The actual physical safety of people. And so we see a lot of really good discussions around the flexibility and all the benefits that come with this revolution that IT has produced, right? But how do we apply that appropriately in the OT space to get the benefits, but offset some of these potential real-world ramifications we can see with security, resiliency, integrity, etc. That you can't just reboot a line. Sometimes there's a lot of physical danger there. So it's a really interesting balance that we see relatively conservative customers going through.
I can build off of what Leonel said. I think what we see is that, as you move faster, and I think that's like, we do things very fast. I mean, like we are on demand, like our paradigm is like on demand custom parts, right? And so what you see is that as you speed things up, sometimes the boundaries of like the traditional boundaries of like design and prototyping and validation and then cutting to manufacturing, those start to get blurred. And sometimes they very much overlap. And so we see the same thing, like how do you reconstruct, the old paradigm and the old way of doing things in a way that is agile, that responds very quickly. And I think what we have seen is that, over the last 3 years, 4 years, is that some customers were coming to us very early and saying, they were anticipating these types of changes to their business models and saying, we know we need to get faster. We know we need to get more adaptable. We have customers who have very long supply chains of, it takes them many months to get a custom part or to get a low volume production run of assembled parts. And they're like, we need to move faster than that because there's advantages to that, right? Like the rest of the business can move faster. We could do this piece faster. And what we saw is that some customers were starting that very early. I think what we have seen over the last year is that with this massive disruption with COVID is that it's actually accelerated that conversation with customers about how do they get agile. And now not only do they see it as an opportunity, but some of them see it as an imperative, right? And seeing that the world is changing and that, speed and agility is not only just an advantage, but it's actually just like part of the way that companies are set up. And I think you know, you look at like electric vehicles, and like there's some industries that I think are doing really well, showing, you know, a successful path.
So why don't you guys talk about some of the technologies you're excited about?
I think one of the things kind of to go a level deeper into agility is, you know, traditionally with manufacturers and industries, they're kind of risk averse by nature. But now that, you know, companies are seeing all these pressures and the impact of supply chain disruptions, or the impact of not getting the product into market fast enough to meet an addressable need, there's things that are emerging where, what if we had digital simulation capability? What if we had augmented reality? What if we had the ability to 3D print this or do design feasibility on that, right? And I think those technologies I'm definitely seeing emerging and connected to that. Also a lot of like edge computing, you know, on-site capabilities to connect assets, you know, going back to the point brought up by Kyle about how physical assets becoming connected opens up another issue. But those technologies, the ability to understand and predict what's happening on your manufacturing lines downstream, and then also the other technologies that help you design products and help you to do like end-to-end visibility of how you're manufacturing or how your ability to get something into market is actually within line of sight or not. I think those two things, kind of those two pressures are what's driving some of the technologies I'm seeing being adopted today.
Okay, that was fairly exhaustive. I didn't say exhausting, I said exhaustive.
They could be both though. It could be both.
Does anyone else want to add anything? If you guys keep going in order, I'm going to be really mad.
You want us to get out of order on purpose.
And I want you to talk to each other so I don't have to ask as many questions.
I think that means I have to jump in. So I mean, I think the list can be pretty extensive for us. I think one, maybe not a manufacturing technology, but like something we're really excited about is just the connectedness. Like I think we look at, it's a term people use, but like digital thread, like how do you create connectiveness of data along the life cycle and then use it purposefully so you can move faster? I think that is like really exciting to us in areas where we're making investments and trying to drive impact for our customers. I think on the manufacturing tech side, it got brought up, but like 3D printing, like additive manufacturing is the term we tend to use. It is not a panacea in terms of like, it does not cure every manufacturing need, but it is very useful if put in the right places. And I think what we see is that it is getting better, more capable, and more mature, and people are finding those right use cases, whether it be direct printing of parts for, you know, early validation, so you can go to market and go test it and go figure out what your customers need, and then quickly adapting to a high volume if necessary. I think like that's really exciting to us because I think it gives us a wider range of ways to serve customers that allows us to move quickly, right? Like the high quality when you need it for the high volume, and then the speed and cost where you need it at different periods of the life cycle.
Yeah, and I would add to that, ubiquity of compute is important and additive, but all of these different manufacturing processes and mix and match, and it's really about orchestration of flexible manufacturing lines, right? So a trend we're seeing is independent cart, where you don't have a conveyor belt that everything has to go the same place, right? You can actually railroad things and have individual items go. So you have the concept broadly of, we call it a SKU of one or a lot of one. How do I allow a custom manufacturing for each item and mass customization, track and trace down at that level? And so ubiquity of compute, bringing compute all the way down in the architecture, is really attractive, but it's a tool. And what I can do with that is start to drive this mass customization concept, and then doing compute at the appropriate level in the architecture. You know, I can do signals analysis down in a drive. I could never pipe all that data, gigabytes of data, up to the cloud. Even if I could pipe it up, by the time I got an answer and back down, the response would be irrelevant. Whereas just the signal, hey, you have cavitation, just sending that signal up to the cloud is important because then it can be contextualized to other levels of data. I only get cavitation when it's transitioning from freezing to cooling or cooling to freezing outside, right? Or something like that, which is a real example I had to deal with at a plant in Wisconsin. And
So,
so
so you guys have given us kind of a sampling of how you think about these things. We have a lot of university people, mostly university people in the audience. Let's talk about like kind of what they should be thinking about and how you might work with them, and you know what are the kind of good and bad of working with universities, because they all probably want to work with you guys.
intellectual property. I mean, just a
Is that good or bad, Kyle?
it's great and it's horrible, right? So when I'm dealing with a professor, when I'm dealing with a university, right, the number one problem I have is the impedance mismatch between how we have to deal with intellectual property and how we have to have determinism and understand the value, you know, what's the risk I'm exposing, right? What do I have to pay? Because I have to make a business plan to invest with the university. Now, that business plan should include non-technical elements because I have systemic relationships for recruiting. I have all these other dimensions I want to engage with the university on. But when it comes to tech transfer, we have to have clean, simple, predictable frameworks for dealing with intellectual property so that I can get lawyers and contract management out of the way. And lovingly, I say the geeks can just talk and share the problem and let the magic happen. If there's any hindrance in the free flow of information in the relationship, we're artificially, slowing down the process.
So you never want to see a lawyer when you're dealing with the university.
I want to no. I want to see a lawyer because I don't want to talk to a judge. I want to see the lawyer. That's a rule. My lawyers have taught me this. No, the critical element is we do our work up front. My job, my fundamental job with the researcher is to enable. I want to do my job. I want to sweat so I don't bleed. I want to get it done, and then allow common sense frameworks so that when we flavor a scope of work, ideally what I want to do is write a scope of work that's on top of an agreement, and there's a flavor of the intellectual property arrangement that's just called out in this SOW, and it's over. The lawyers are gone, everybody's happy, and the geeks can just go and churn, and we know that if something cool falls out, we know that the institutions will be taken care of because we've thought it through.
Guys,